Okay, so
show
we're live right now. So this is, oh my gosh, I messed up. I didn't broadcast our entire lesson 8, so here we are again. I think I did this one before. So Denise Dosher, Emily Sunday for group 8 meeting replays. We've already done all this, so we're just gonna, we took the quiz originally, only had a couple questions on the homework, and we missed 4 questions. We reviewed them. They were simple errors, and we corrected them and got 100%. So what do you want to do, Emily? Do you want to go over?
I didn't know I could screen share what we got on our first one here. If I can. Sorry, I'm trying to find you on my million tabs I have up here. Here you are.
Yeah, I'm really sorry.
So,
yeah, we worked through all the homework. I mean, we went through everything. This is so it's not like we didn't do anything.
Yeah, here's me too.
We went through all this stuff. Anyway.
So yeah, I guess.
So then so we can just review the quiz and real quick. Do you want to do that?
Yeah.
Okay. So we're going to just review the quiz that we took originally and then just tell you the answers that we fixed. So number 1 was true. Number 2, we selected categorical as the brand of toothpaste.
Mm-hmm.
3, we got 100 as a parameter and 112 as a statistic based on the reading and the homework. Question 4, Rothman City has 4 distinct neighborhoods. It would be a stratified sample. 5 would be a cluster sample. 6 would be a simple random sample. 7 would be a stratified. For question 8, we pulled up a histogram for this Crossroads spreadsheet at SPSS, and we rounded to the nearest the 3rd decimal place for the mean that pops up under the what am I trying to say? Under the spreadsheet, it was 4.771. And the standard deviation was listed on there already, was 1.912. Do you want to do anything, or do you want to just talk?
I can do some too.
I'll just finish 10 and I'll let you take it from there. So 10 was true. We did pull up a histogram. So anyway, go ahead.
Okay. Starting on the following, it gave us information on representative temperatures. And we took that information in the following table and plugged in the temperature and subtracted that from the sample, or excuse me, from the mean, right? Sample mean. And by adding all numbers up, and we divided that by 4, and then we got, let me get my notes here, sorry. So we got, let's see, for the A, we did 3.8. This is the one that we actually missed the first time because we rounded the decimal.
Yeah, instead of getting
38.08.
Yeah, so that's why we were off.
We went back and did it again, and we had 38 point, was it 0? I'm trying to find my calculator here.
0.075. So it's
38.075, yeah. So then we took that 37.91 and subtracted it from 38.075 and got negative 0.165.
Yep.
And when we, is that as far as we go on that one? Sorry.
Yep.
Yeah. And then for the next one, for B, we took that 38.075 and that 37.25 subtracted from that. And we got
681, was it?
Trying to find my notes here now. 0.681. Yeah.
So we just had the desk. Everything's gonna be messed up on this table because of the stupid rounding. I don't even know how that happened. Yep.
13. When you look at all those things, none of them were equal to that. So it was D. None of these are correct. The standard deviation of the temperatures, we got the answer of 0.715. Trying to see how we got that. Was that taking the square root of the total minus, or so the total of 4 minus 1 is 3. So we took the square root of that and divided that by the decimal of 1.5342. Is that right?
Yeah, we divided 1.5342 divided by 3. So we used the formula of the sum over n minus 1.
Divided by 3, and then we square rooted that answer.
Right. That, and you get the sample variance, and then you square root that, and you'll get the standard deviation. So we did, yeah. So we got 0.5114, and then that you have to do the square root of, which would be this 0.715.
Yeah, and then the standard deviation can never be negative, so it was false for 15. Do you want me to do?
Doesn't matter.
It's
up to you.
Go ahead. You can do the next few.
So we're on 16, right? Yeah. So for 16, we put extra dural because the standard deviation was the lowest, and it shows the least amount of spread. So the numbers were closer together. So it'd be the more consistent temperatures. Question 17, the third quartile. It's kind of self-explanatory. The first line is the minimum. The next is the first. The median is a black line. It's the second quartile, and then so forth. So we got 8 for that. 18, the percentage between 4 and 8 hours. 4 to 6 is 25%, and 5 to 8 is 25%. So that became 50%. Question 19. I had to do this because I understand this. I didn't understand this, so I had to write it out. So just drawing a bell-shaped curve, the median would be, what I did was I took 1.59 and 2.52, added them together and divided by 2, and I got the mean of 2.055. And then question 20, on the bell curve, on the bell, if you take the median and put a draw line in the middle, and you put your standard deviation. Are you there?
I'm here. Sorry, that's happening. That's frustrating.
Well, I just went through all of I went all the way down to 21, and then 22, I don't know if you want to do, or you may do more. I'm fine with whatever you want to do.
So we were 19. We got 2.055, 20, 0.233, and D on 21, and then 22. So what is the probability that a randomly selected student will score above 542.3 on the GMAT? So we took it and the mean was the same as the score. We subtracted it was 0, and we divided that by the standard deviation, which would make it still 0. And you plug that into the applet, it makes that 50%. So we put our answer as a decimal of 0.50, coming out as 0.5. If you want to add to any of that, let me know too.
Nope, it's perfect.
And then the probability for scoring below, we used the applet on these pretty much, yeah. So we just
That's
basically
sorry.
see.
23
Oh,
originally because we didn't put the third. We put 0.68 instead of 0.684. I don't know why.
Right. So when we plug that into the applet, we highlighted to the below, everything below the 600 mark, and so we got that 0.684. The other one, we highlighted everything above, and we got 0.32. I'm on the old one, but then we changed it to 0.32. What was the rest of the decimal on that one?
0.31.
Oh, 0.316. Is that the one?
Yeah.
316.
Yeah, so we fixed those. I mean, I missed 4 questions, but they were all, stupid things.
Yeah. And then 25, let's see. 25, we did the 10th percentile, just plugged it into the applet, 0.10. And we got 387.67, rounded that to 388. And then for the 90th percentile, we got the z-score, right? We figured out that what the z-score, no, we had the z-score, we figured out what x was and plugged that in. I don't know if I'm making sense. I'm just looking through this. Anyway, we got 690.7, rounded that to 698.
Yeah, we did the formula. We had the z-score, which is the same as 27, but it was a positive. It was 1.282, and then we plugged it into the the z-score times the standard deviation plus the mean.
Right.
Yeah.
And then on 20, or excuse me, it's different than on here. On 27 and 28, we basically took what the percentage was from the different quartiles. So the first quartile is 25%, so we plugged that into the applet of 0.25. And we figured what the score was from that and plugged that z-score in to the equation times the standard deviation plus the mean, and we got 461. Then on the next one, we did the same thing, but we did 75 percentile, highlighting it to the right because it's above.
Mm-hmm.
And we got 623.54, rounded it to 624.
Yep.
That makes sense, I guess.
Yeah. So I'll do 29. So this formula is just where it says the population mean of the sample mean is the mean or something like that. So it's the same as the mean. So it would be 542.3. And then the formula for 30 standard deviation of the distribution of sample means is standard deviation over the square root of the sample n, which would be 15. Right? Am I doing that right?
Uh-huh. We divide it by you take the standard deviation and you divide it by the square root of the number 15.
Yeah, so we got, and then around the third decimal place, we got 31.123. And then 31, we did the formula, the 600, which is your x minus the mean, 542.3, over the standard deviation divided by the square root of 15. And then we got a z-score of 1.853. We plugged that into the applet and we shaded to the right because it said greater than, and it would turn out to be 0.032 when we round it.
Yep.
So yeah, I think we're okay. We worked through some problems. Yeah, but I mean, nothing. I think I had the most problem with the first quartile, third quartile, 29, 30 on the homework, but we worked through that. Emily really plugged in on that. And then anyway, so yep, I think we're good. We retook the test and got 100. So is there anything you want to add to that?
Just that I think it'll be awesome.
I hope so.
Yeah, and I think you had a lot of good input on some of those ones that we went through that we were confused on, so that was helpful with the.
Yeah, I think we work well together.
So
yeah, I think we work well together. There are things that I understand that she doesn't, and there's things that she understands that I don't, and we were able to help each other out, work through those. So
good collaboration.
That is good. So, but I think.
Okay.
All right.
Thank you. Have a good one.
Sunday. Second go with this. Hopefully it recorded. All right.
Hey, good night. Bye.